All right, we're recording. For people listening at home, thank our good compatriot here for saving my bacon. This is This is an example of something relatively big that we want to factor by GCF. This is dealing with the worksheet called In-Class Project 62. For people at home, I'm going to email it to you today. So watch this first, or you might get the email first, whichever, and then step through this. Now, looking at the numbers so far, just to summarize the last 30 seconds, the biggest number that can divide into all three of these is 8. But since the first term is negative, you pull out a negative version. So it's negative 8. Now, question. Do these have any letters in common? Maybe. Like what? Brennan. Just go one letter at a time. What's the first letter that you even talk about? X. How many X's do they all have in common?
How many what?
How many X's do they all have in common? Like how many X's could this, and this, if you had to steal the same number of X's from each one, how many could you take without collapsing something? Well, you're talking about this, and this? Like there are 15 X's here, if that helps.
Oh, yeah.
So how many X's could you take out before you run out? If you have to take the same amount from all three. And this one you could take away 15, but this one you can only take away 10. So how many X's could you take away from all three terms? 5. How do you get that? Why 5?
Because, well, I mean,
Which term caused that?
the first one.
First term. This one only has 5 X's to spare. So you could pull 5 out of here and it runs out. Pull 5 out of here and it'll have, how many left, by the way? 5. How many will be left here? 10. We'll do that in a minute. Somebody else do the Y's for me. Trust.
3.
3. It looks like the most we could pull out is 3. So Y to the third. Correct. And then how many Z's could we pull out? 1. Over, where is it? Here. This can only spare 1 Z. 1 Z. Isn't that the name of the whole one-size diaper? Yeah, question. Was I saying? Well, there are 3 Y's. This is sort of like Y, Y, Y. And this is Y, 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 Y. So how many Y's can you steal out from each without going negative? Does that kind of make sense? So this, you can take all 3 Y's out and you'd have none of them left. You'd still have 3 left here and you'd still have a whole bunch of them left here. But if I tried to take 4, I'd go into debt here. So that's not legal. Okay, so you got Y to the third and Z to the first. It's up to you if you want to put the 1 here. It's totally up to you. And that covers the letters. You are looking at your GCF. It's a big multi-part GCF. Can somebody tell me what's left over? You should have 3 terms, but they should all be smaller. Can somebody do the first term for me? Be brave. Be reckless. Leap into the beyond. Go.
2.
Positive 2. First of all, explain how you got that.
Because when the negative appears coming back in, you switch the signs. Also, it's negative.
Yeah, first of all, it's positive because you pulled the negative out. And then, why 2? Why not 5?
Because it's 16.
Right. You started with 16 and you divided 8 out in front. What you're doing is dividing it by negative 8 x to the 5th, y to the third z. So dividing by negative 8 is going to be positive 2. How many x's are left? None. So you skip that. How many y's are left? None. How many z's are left? 3. 2z to the third is your first term. Does that make sense? Put a plus. Isabella, take the next one. Start with the number. You pulled out, you divided by -8, and you started with 80. What number is that going to leave you?
10.
Yeah, 10, and then what kind of 10?
-10.
Good, because positive 80 divided by -8, looks like it's going to be -10. Question, how many x's are left? You pulled out 5 of them. 5. X to the 5th. How many y's are left? Here's how many you pulled out. 3. How many z's are left? 0. None of them. So you can skip that. And you're done with that term. Everybody feeling kind of comfy on this? Okay. Eric, take the next one. First of all, is this next one going to be positive or negative?
Positive.
Positive. You're dividing -8 out. So -24 divided by -8. Positive what? What's the number going to be?
3.
Good. 3. How many x's are left?
10.
10. X at 10. How many y's are left? There are a lot. 97. Y to the 97th power. And then how many z's?
9.
9, because you took out only 1. That is the end of the problem. Does that make sense? Do it step at a time, and it makes it a lot easier to handle. Don't try to do it all at once. It's kind of like Thanksgiving. You don't eat the whole Thanksgiving turkey at once, you choke. You do it one bite at a time. I've never tried doing the whole turkey at once, but I don't think it would end well. Questions? I'm going to give you one more spin on this because the worksheet is going to do this. How much time? We have a decent amount of time. Wow. Quick example here. What if I did this? X squared parentheses 2x plus 1 plus 5x parentheses 2x plus 1 plus 7 parentheses 2x plus 1. And I would like you to factor this. Again, a GCF, gentlemen, Rob, John, I would appreciate you not talking or communicating with each other. Understood? John, was it good? Let's do that. Let's figure it out. So, does anybody see anything they have in common? I warn you, it's a little strange. The parentheses. Let me do a little code here. Little miniature example. X squared A plus 5xa plus 7a. Can anybody see the GCF now? Josh, what do all three of these have in common? They all have A. If these are all multiplied in common, like they distributed times A times A times A, who do you divide it back out? Like, what would it look like? What would the leftover parentheses look like? What's inside? What's left over after you steal the A's back out? Just read them off one by one. Yeah, the A is out in front, so all the A's should disappear. What's left? How do you say that? So the second power is called, I stink at picture. Squared. A is x squared plus, and then what's left? 5x, good. Plus, exactly. See how that works? If I did a distribution problem, if I distributed the times A times A times A, I'd get this. I'm just going backwards from that. I'm stealing the A's back out in front, dividing it out in front. But I'd like to point out, this thing looks big and clunky. A lot of people would say, hey, I'm going to distribute, I'm going to distribute, I'm going to distribute. Can you? Yeah. Would I? Not in this case. If all three of these are exactly the same, that's unusual. I'm going to give this parentheses a nickname. I'm going to call this parentheses A. Guess what I'd call this one? Yeah. Right.
No, A.
A, why? How come?
Because it's the same
It's
thing.
the exact same one. parentheses are the exact same problem. So instead of pulling an A out in front, what would you pull out in front? Could somebody actually do this for me? Do the factoring from beginning to end. Maybe. What would you pull in front? It's a parenthesis.
2x plus 1.
Correct. I'm pulling the 2x plus 1 out in front as the greatest common factor. Once you do that, you should have another parentheses with the leftovers. As my mom always says, whenever you have leftovers, wrap them up, otherwise it gets stale. She's so cute. So, what's left over? Jonah. After you pull the parentheses all the way out in front, what's the leftovers? Well, just like erase in your mind all the parentheses. What's the, read what's left. I think this is gone.
X to the second.
Yep.
Plus
Plus.
5x.
Yep.
Plus 7.
You're done. That's factoring by GCF. Even if you have a strange parentheses wrapped GCF, you can still pull it out in front. Question?
Okay, so we have to write the answer like that.
This is your final answer. The stuff in the middle was just to illustrate.
Well, I did, and
Okay.
then,
Huh?
and then, there's a problem with that, but then it's like, they, like, it's that, but then it's negative 8x cubed, and then.
Which one are you looking at?
16.
Oh, I think I remember that
They all
one.
have an x in
Yes. Okay. Number 16. Oh, that's fun. Oh, number 20, you saying?
Yeah.
Yes. Number 20, the parentheses is a GCF. You remember the big monster one we did over here? There was a multi-part GCF. Like there was a number they had in common, pull it out in front. By the way, look at number 20, if you have the worksheet out. Does anybody see the number that they all have in common? Josh? Definitely, x plus 1. Does anybody see like an actual number they have in common? Yeah, Rob. 4. Have you noticed the first term is negative? What would you pull out instead? Negative 4. So the very first thing you pull out is negative 4. Do they have any regular x's in common? If so, how many? 1. So you pull out a negative 4, then you pull out an x, and then you pull out one more thing. A relatively complicated looking thing. Got it? X plus 1. The GCF on number 20, it should look like this. Negative 4 followed by an x, followed by an x plus 1. And then you can parentheses for the leftovers. That's how you do that one. So I'll let you do that on your own. But whatever's left over after you divide all those out front, the x plus 1 is going to be gone. So don't write those in here. That's divided out in front. 1x is gone from each of those, and all of them are divided by 4, negative 4. Good question. Good.
And then, yeah, for 16.
Yes.
I tried doing that, like, wouldn't it, like, not work, because, like, all of them are divisible by, like, 15's not divisible by.
Well, actually, 15 is divisible by what? 5.
Like, yeah, that's what I did, but then, I got confused.
You're wondering about the x's?
Oh, yeah, no, never mind.
Okay.
That was me.
There are some problems where the x's will not pull out because you don't have them in common. The only thing you can pull out is a number. So yeah, you should be good on that. Good question. Any other questions on this? Alrighty. Let me see. I have one more piece of notes, which should take about 5 minutes, and then the rest of the hour is yours. There's one method of factoring I need to show you today. Is everybody okay on this part? Everybody got this? Left-hand side? Okay, John, where's the paper? Just take it out, all the way out. Let's try again. See notifications. try this. Example. X, go ahead and write this down. X cubed. Done. X cubed plus 5x squared plus 3x plus 15. Is there a GCF here? Let's see. Yes. Yeah, go for it. Actually, while you're going, is there a GCF in here? Is there a number that goes into all four of those at the same time? Like what? This one doesn't have an X on it. Good guess. 3 of them did. Correct. There is none. You can go ahead. Didn't do that. Get down. There is no GCF. By the way, technically there's always a GCF, but it's kind of boring, and you almost never use it.
Is it one?
One, yeah. That's actually kind of a trick question on the worksheet. They're going to ask, what always goes into it as a GCF, but you almost never use it? One. There's actually another one too, but I'm not going to spoil it for you. I think that might be an extra credit problem. So, maybe kind of, sort of, no comment. So, there's no GCF. However, I would like to point out a method called factor by grouping. Factor by grouping. The only method of factoring we know so far is GCF. There are 7 methods. We've covered 1 so far, GCF, which is the most important. You always do that first. I want to show you factor by grouping today. GCF has failed us through no fault of its own. It looks like it's prime. What if, for my own mysterious reasons, I just let you play with the first terms and just ignored this? Again, for my own mysterious reasons that I'm not going to reveal for another 2 minutes. If you just play with this first pair, is there a little miniature GCF just in that pair? Go. X squared. Pull that out for me. What would be the leftovers? Andy, take over. What would be left behind if you pulled X squared?
X and 5
And
plus 5.
plus 5. Let me see where they came from. Now, it's still a mystery as to why would you just do half of a problem? That's weird. I agree. Normally you're not supposed to do that. But for my own mysterious reasons, just because I'm feeling mysterious. What if, for an even more mysterious reason, I just let you play with the last pair? Ignore everything except the last pair. John, help me out with this one. Is there a GCF in this pair? Is there something that goes into both of them? A number that divides in both? Like what? It's a number. No letters. 3. Now, you see this plus here? Don't get rid of that. Plus 3, and then if you divide the 3 out, what's left behind? Tracy? X plus 5. Interesting. For my own mysterious reasons, why I'm just going in, I'm not telling you. Does anybody notice anything suspicious about this? Go. You notice the parentheses are the same? It's kind of like this problem I did over here, like in number 20. I erased it, of course. That's a GCF. It was hiding. The GCF is X plus 5. What do you do with the GCF? You divide it out in front. You pull it in front. I'm going to pull the X plus 5 in front. And can somebody give me the leftovers? I always wrap them up. Rob, help me out here. what's the leftovers?
X squared plus 3.
X squared, and a plus, and a 3, and congratulations, you just factored by grouping. When does factor by grouping work? It doesn't always work. First, you have to have 4 terms. Or sometimes an even number of terms. I have seen big factor by grouping problems where it's 6 terms or even 8 terms. Usually it's 4 terms. If you have 3 terms, it doesn't work because you can't break them into pairs. And the second thing is, after pulling what I would call the mini GCFs, after pulling the mini GCFs, the leftover parentheses must be the same. Comma, for this to work. Go ahead and write that down. After pulling the mini GCFs, the leftover parentheses must be the same. For this to work. There's one last thing, bless you. This is one rare case where GCF equal to 1 might be useful. And for anybody who didn't see it yesterday, GCF of 1 is usually boring and pretty useless. Like, you don't have to write this down to watch. Can I factor this, 5x plus 3? So you tell me, does that factor 5x plus 3? Is there a GCF? Yeah. I'm sorry? 1. What would happen if I actually pulled out a GCF of 1? I mean, what's the leftovers? What do you got, Fred?
Would it be,
Don't work too hard.
5x plus?
Yeah, 5x plus 3. Okay. Now what? I said, but wait. There's another 1 hiding in there. I can pull out another 1. Oh, excitement, my pulse is pounding. Wait. You see where I'm going with this? Now, if this amuses somebody, you can do it for hours as long as you have lots of paper and nobody minds. It's legal. It's strange. People look at you funny. But, and then you come back like 8 hours later. Hey, Mom, I got like 1 to the 3,489 power times 5x plus. My reaction is, really? Yeah, honestly, what's the point? So in other words, pulling out a 1 is usually useless. Factor by grouping is one of the rare times where pulling out a 1 might be useful. Yeah, perfect. Questions? All right. The factor by grouping is going to be on the last page of this. You notice there are 2 different factoring methods. The problems up to number 20 are just plain old GCF. Then the problems 21 through 30 are factored by grouping. And then there's an extra credit problem, factored by grouping, and I gave you 6 terms. Enjoy. Any questions so far? Quick question, what do you call a problem that does not factor? Prime, P-R-I-M-E. If something does not factor, other than a GCF of 1, it's prime. Quick question. Susie. Everybody okay? Okay, the rest of the hour, you may work on this. If you are quiet and bring your desk chairs back when you're done, you may work in groups. Okay, John, can I talk to you? Somebody hit the stop button there. People listening at home, bye-bye.